Hi guys, welcome back to my channel. Thanks for such a good response on my previous videos. Keep supporting my channel. Don't forget to like, share and subscribe to my channel. So I am doing videos for my college purpose. Your likes will determine my marks. So don't forget to like this video. Do support my channel.
So today's topic is on minimization of DFAs. So let's get into the topic. Introduction to DFA minimization. Deterministic finite automation are used to recognize patterns in languages. Minimization is a process of reducing the number of states in DFA while preserving its language. A minimized DFA is more efficient in terms of memory and processing time during the computation. So here is one of the example of DFA problem which is used where your states are Q1, Q2, Q3, Q0, where Q1 and Q2 are the final states and Q0 is the initial state. Now let us know what is the importance of minimization. Minimization of DFA leads to simpler and more manageable automata. Reduced state complexity results in faster algorithms for pattern matching and language recognition. Minimization plays a crucial role in optimizing software applications that utilize finite automation. So here is another complex of DFA which will be reduced into a minimized DFA, which we already shown in the picture, where the final state is Q4 and the initial state is Q0. The next one is overview of DFA structure. What is a DFA structure? DFA consists of finite sets of states, alphabets, transition functions, and accepting states. So the alphabet here in the diagram, we can see the alphabets represents this symbol, whereas the transition represents this symbol, and the number of states represent this symbol. Now, so each state represents a unique configuration of automation during computation. Transition function dictates how the automation moves from one state to another state based on the input symbols. So here is a simple DFA problem where Q0, Q1 and Q2 are the states, where A and B are the inputs of the input symbols of the or the alphabets of the DFA, and initial state is Q0, final state is Q2. Uh, then transition functions are also described here. So let us go to the next state. So next one is criteria for minimization. Two states in a DFA are equivalent if they lead to the same behavior for all input strings. An efficient minimization technique identifies and merges these equivalent states. The goal is to create the smallest DFA that recognizes the same language as the original. So our goal is to minimize the DFA in such a way it creates the smallest DFA that has leads to the same goal. The next one is methods of minimization. The most common method of DFA minimization is partitioning refinement algorithms. Another approach involves constructing the my-Hill-Nero relation to determine each state equivalence. Both methods ultimately aim to reduce the number of states while maintaining the language recognition. Partition refinement algorithm. So this is one of the algorithm for DFA minimization. The algorithm starts by dividing the states into two groups, accepting and non-accepting. It iteratively refines these groups based on the transition of the states in each group. The process continues until no further refinements are possible, resulting in minimized states. So in this algorithm, first states are divided into two groups, accepting and non-accepting. So these iteratively refine each group based on the transition from the state in each group. So this algorithm is also known as Paragon Parallel Architecture Aware Graph Partition Refinement Algorithm. It was proposed by Angan Zing, Alexander Labris, and Patrick Peskuner. Next theorem, which we use for minimization of DFA, is Myhill-Nero theorem. It is a theorem provides formal method for determining state equivalence in DFAs. It states that two states are equivalent if they cannot be distinguished by any string in the language. So it states that if the two states are equivalent, how will we define that two states are equivalent? That it cannot be distinguished by any string in the language. So any string in the language will be not be different. All will be same. This relation provides a basis for constructing the minimized DFA systematically. So it helps for providing a DFA systematically. So here is actually a diagram that shows the Myhill-Neurer theorem and a non-systematic running time. The next one is explain DFA minimization. So let us actually go through this sum to know what is DFA minimization. Consider DFA with 5 states that recognizes language of binary strings with an even number of zeros. So when we tell that it is 5 states, so there are 5 states: Q0, Q1, Q2, Q3, and Q4. So it languages for binary states within even number of zeros. So it states that it has only two inputs, that is 0 and 1, and it has even number of zeros in it. So that means that in a DFA problem, number of zeros should be even and number of ones can be anything. After applying minimization techniques, the DFA can be reduced to just three states. This example illustrates the practical benefits of DFA minimization and simpler automation. We have actually solved many sums related to this DFA minimization, where there are 5 to 6 states and we have reduced it to 2 to 3 states using the transition functions. So here is an actually example of minimization where they reduced the 5 state DFA into Q0, Q1, Q2, and Q3. So let us go into the next problem, next topic. That is application of minimized DFA. What is the real-time application of minimized DFAs are it is widely used in compiler designs for lexical analysis. So it is used for compiler design for lexical analysis. They are also integral in network protocols for pattern recognition and data validation. Additionally, minimized DFAs enhance the performance of text search algorithms. So they enhance the performance for text search algorithms where the compiler is high level language, low level language. It is converted into low level language using this minimized DFA for lexical analysis. Next is conclusion. So thank you. Today's topic is concluded by saying that minimization of DFA is an essential aspect of automated theory and computer science. So by reducing the number of states, we enhance the efficiency and performance algorithm. Obviously, when the work can be done in a more efficient way using less number of sources and less number of states. It is a good algorithm. So minimization is very efficient by reducing the number of states, enhance the performance of the algorithm. Understanding and applying minimization technique can lead to significant improvements in various applications. So thank you for today. Please do subscribe, like, and watch my